show kids like I'm talking about like in the 18th century and earlier, you know what they played with? They had sticks.
I know, that's so much fun. I love playing with sticks.
Okay, then maybe you need to go find the time machine and go back in time. Then.
How many fingers are on your hand,
Math is what has allowed us to pull ourselves from the pain and the anguish of hard life into nice, comfortable, that we complain about things like, my mattress is too hard. Without math, your butt would be sleeping on the ground, you know?
That's hard.
I guess you've done that.
All
I
right,
have done that
I've slept on the ground plenty of times, and I'd rather sleep on a mattress.
actually. I love sleeping on the ground. I like sleeping outside.
But there are some times where the ground is way comfortable. Like
Sometimes.
it's almost too comfortable. Like,
When there's a nice soft bed of moss or something like that. But then it's replicating what a mattress does.
no, I'm talking about like the shit up ground. Like
I'm talking about like rocks.
I'm not talking about rocks.
All right.
I'm talking about really uncomfortable carpets. Like so, you know, sometimes in your house you have really uncomfortable carpets that hurt when you walk on it barefoot, and you just like rest on that, and it's
Yeah,
comfortable.
I know.
Like,
Why can't you start living now?
All right, let's get something accomplished here. Any questions on the homework? 1 through 12. 1 through 12. And you probably thought it was pretty easy because this is your second day, and after you struggle through a little bit, you see the pattern, and it's like, okay, this is not bad.
I gave up.
Okay,
I think 11 to 12 were just easy.
so Wes, you got them all, or you want to see one?
I want to see 5.
Number 5 starts off with a triangle that looks like this. It looks like it's isosceles, is it? It is. So we know that this side is 30, this side is 30. It's a right triangle. You're told that y is this value right here. You're told that this is 70 degrees and anything else, and that this is x. And that's what. Now, obviously, you're trying to find out x and y. Okay, it's a isosceles triangle, right? So I'm going to look at, we'll do x first. And you can do y first. It doesn't matter. Can you do y? Yeah, you can do y first. It doesn't matter. I'm going to do x first. I'm looking at the left triangle. So, I know that this is 70. I know this is 30. I know this is x. So now you, in your head, you label what you got. According to 70, x is what? Hypotenuse, adjacent, or opposite? So I got opposite is 30, adjacent, opposite, or hypotenuse. And I got the hypotenuse. So opposite and hypotenuse, which trig ratio? Sine, right? I'm gonna get in trouble for telling you guys, because you guys are gonna go to your next math teacher and say sin, and they're like, what? Who was your math teacher? I agreed. As long as you keep that in back of mind, but don't ever point to me as the one that taught you that. All right.
Why not?
Because it's sine. I know I said sin a bunch of times because it's funny, but you guys are gonna say sin. Like I said, your next math teacher will say, who's your math teacher? Well, everyone does that.
The
But,
problem is it is a sin, so.
all right. So Wes, give me the setup. The sine.
Sine x.
Well, we know that
No, 70.
sine of 70 is equal to.
X over 30.
So therefore, what do we got to type in our calculator?
30 sin 70.
30 sine 70. You're done. There's x. To find y. Okay, I don't have another color here. Well, if this is 70 and it's a isosceles triangle, 30. So this side is 70. So now I know the.
It's going to be.
Well, now I know the. It is right. Now I know the hypotenuse. I'm trying to find the adjacent. So it is. So this is going to be cosine 70 is equal to the adjacent, which is y, over the hypotenuse. Why do I hear a voice or voices talking over me? Please stop. Any different or the same thing except it's cosine?
Nothing.
Yeah, so it's 30 cosine 70, you're done. Anybody else? All right, here we go. Number 1, check your work. Now this is both x and y, and they rounded. It looks like every answer is to the nearest whole number. Okay.
Yeah, I do too.
Well, I didn't do
Number X is 21, or number X. Number one, X is 21, and remember this will be approximately because they did round. And Y is 28.
Will we be wrong if you don't do the approximate symbol on a test?
I will certainly circle it, point out, but you got to get comfortable with the fact that whenever you take,
Yeah.
literally take the square root, so you're changing from exact to approximate, it's wiggle wiggle. All right, two, X is 102 and Y is 64. Number three, X is 89, Y is 117. Number four, X is 54, Y is 64. Number five, X is 28. We just did this one. Oh no, actually, we didn't actually type in the calculator. X is 28, Y is 10. Number six, X is 28, Y is 26. And then 7, 8, and 9 are you're calculating angles. So 7 is 26 degrees. This is the one where you have to use the inverse function. Number 8, D is 67 degrees. Number 9, X is 9. That's a distance. And V is 63 degrees. Number 10, same thing. You get a distance and a degree. X is the distance, and it's 9. Apparently, they like their 9s. And V is 42 degrees. Number 11, V is 37 degrees, and W is 106 degrees. And the last one, number 12, X is 20, and Y is 10. So what would these look, now that we're done with the trig part, what would this look like on the test? 1 through 12, that's going to be the questions right there. Now that's you know, I don't know, maybe a sixth of the test will be the trig stuff. But yeah, if you were very comfortable doing that, then this is like easy money.
We're never gonna do the Y.
Well,
What do you?
hopefully you don't forget to do that on the test. All right. Okay. Today is a really easy day. I think so.
Is it the angle of compression stuff?
Angle, elevation, angle, depression. So for those of you that are depressed, I apologize. We'll try not to make fun of anyone. All right.
Taxes, income taxes.
Oh, yeah, I lost your taxes. Wait, take my knife.
No, there's no tax questions. All right, everyone look at the board.
Give me your money.
Three, you wait.
Yeah.
Okay. Couldn't tell.
So,
Calendar, and I made this comment yesterday in class, and I said, this chapter just has lots of skills, right? If it was just theorems and logic, we'd be ready for the test after one review. But because there's so many things, I'm gonna give you 2 days. Now, stop and do what I asked. I'm gonna give you 2 exact copies of what the test will look like, just different numbers both times. The first day, I'm gonna go over everything with you. The second day, that would be Monday, you're gonna be on your own, right? And as long as you're working, I will have no complaints. On Friday, that's tomorrow, I'm gonna walk through every single problem with you. You will have no excuses for getting lower than a B on this test. Like, we're gonna stop after every question. I'm like, you got this or you don't got this? And if you say you don't got this, we'll do more until you say you got this. Right? Have your book of truth in front of you. Make sure you know where to look for this stuff. There should be no reason I don't have this. Should be the best test of the entire year, chapter 8. It should be. Well, I mean, I'm a realist. I know it won't be. It won't be. No, actually, no. This usually is the best test because it's nothing but there's no proofs.
Oh, no.
There's not a single proof on the test. It's just skills.
I don't like this.
Okay. And if you can do the skills, you'll be fine.
Will you bet pizza that this is going to be the best test?
I will have someone, if I made that bet, that someone would oh, you mean if everyone gets a B? Yeah. If everybody gets a B or above, I'll buy the class pizza. All right.
Motivation, boys.
In class. All right.
Nobody fail. Danny, don't fail.
Well, you can get a C and still pass.
I know.
So we're betting a B or higher. All right. And it should be an easily accomplished thing. I'll just say the things that generally get kids in problem are the special right triangles and the first thing, that corollary 1 and corollary 2 thing. That usually throws some people for a loop. But they're just skills, right? All right, here's your homework. Hey, there's only 6 of them. That must mean that they are hard. They're all word problems. I don't think any of these are that hard.
God has left us.
We've been abandoned by the
Matt
feathers.
and
God,
Joe,
get off the
you should
football
keep
team.
saying it.
Odin is no longer with us. Odin is no longer with us.
The only time I think that is when I drop the ice cream in the dirt.
That's always the worst.
If it were anything else, I would probably pick it up. If I drop ice cream in the dirt, I'd never pick it up.
God has left us.
This is the 21st.
Today is the
I
21st.
can't believe it's already the 21st.
That means that there are
Of
only
2021 and
10
Biden's
days
already
left of
transferred
in the January.
He's just
He's already
signing a
taken
bunch
off
of,
military flags. Now they all.
Oh,
he's
I
just
love it.
signing a bunch of
Is it
executive
annoying?
orders. And the worst part is he's sending troops back into Afghanistan to be like the world's police. It's kind of stupid.
Yeah.
well, who knows what the future holds?
Nothing.
This is
Well,
why we
uh,
should have the burning of every major city and a civil war. That's what the future holds.
Pretty much, yes.
Yeah.
Well, if you talk about what are the possibilities, that would be
That
a
is definitely
possibility.
a possibility.
Life is not a massive.
It's looking more and more.
I would love to be able to say I lived during the 2021 Civil
All
War.
right. In math, we have something called the law of large numbers. And the law of large numbers basically says that if you do enough of anything, anything can happen.
Can I reject this law?
All right, here we go. So this is the application of right triangles and trig, right? You were fine with the trig we did before. These are pretty straightforward. I will say this. I sat in geometry. You'll get this problem, algebra 2, pre-calculus, you take pre-calculus, you'll get these problems. I paid no attention to geometry, and I got these wrong all the time because I didn't pay attention. And I'll show you why I got it wrong. There is no reason why you should get this wrong because it's pretty simple. Even though there's only a few things for homework, they're really not that bad. If you listen to me, which I never listened to my teacher in geometry, even though she was a good teacher. I listened to her in pre-calculus. I didn't listen to her in geometry
Then why do you teach geometry?
because for me, it's the most fun. I love geometry. It's the most fun. All right. The other stuff, it's like there's little creative thought in the process. Like no other math ever stops me. All the other math that I do that I can remember how to do, it's just like, okay, step 1 is this, step 2 is this. Geometry is the one that like, oh wait, gotta think about it. Right? Oh, gotta draw it. You think? I mean, no other math makes me think like the way geometry does. Quick review: we've been dealing with right triangles and trig. So remember, we never deal, at least until we get to pre-calculus, we never deal with this angle right here, B. So trig will always involve, at least for this year and next year, will always. That's not true. For this year, only involves angle A and angle C. So we have these 3 trig ratios. I told you yesterday there's actually 6 of these because there's one where this is flipped, there's one where this is flipped, there's one where this is flipped. Anybody know what they're called? I'll go ahead and tell you. When this is flipped, it's called cotangent. When this is flipped, it's not called cosine, it's called secant. And when this one's flipped, it's called cosecant. But there are 6 of these. Like I said, and remember that when the first day of trig, and I showed you that page that had all those trig functions on it. Boy, do they get complicated.
So cosine becomes secant and then sine becomes cosecant.
Yeah, that bothers me to no end. Right? Why didn't they make it easy? But for this year, these are the only 3 you got to remember. Okay. If you choose to take pre-calculus, which most of you should choose, if you choose, you only have to take algebra 2 at this school. You have to take 4 years of math, though. So senior year, there will be an alternative math course offered that isn't as challenging as pre-calculus. But for those of you going on to college, and you're going to have to take calculus, you need to take pre-calculus senior year. It will be a joint class with the 11th graders. Like we'll take whoever's the real smart kids in 11th grade, and they will take the class with you in 12th grade. So there's plenty of you sitting here right now that should be taking pre-calculus.
I'm not going to.
All right.
Do we get a choice or do we have?
You do have a choice. It's 100% your choice. But I will say this: if you truly think you're going to college and you want to get into a good college, you need to take pre-calculus. If you want to do anything involving science or math as your future, you need to take pre-calculus. Not because you may use it, but because to get into that college, and you're going to be required to take other math courses in college.
Yes, like.
You stop at algebra 2, you're skipping some math that you're going to be required to do in
Is there ever
college.
gonna be such a thing as a computer programming class?
There could be. We definitely talked about that.
After you graduate.
No, we were going to start it this year. We just we got to wait till the wing is built so we have the classroom for it. So, but we were going to have it this year. We were going to have we were going to make a requirement for all 7th graders to take a typing class. We were going to make it one of the electives that it was going to be coding or maybe computer science basic, something like that. But
Yes.
all right, but hey, if you are truly considering that and you're saying nope, not taking any math beyond algebra 2, oh God, no. You guys, you're going to be taking calculus in college. Right. All right. The way that you remember our basic trig functions, our trig ratios here are SOHCAHTOA. And obviously, since there weren't that many questions for homework, you guys are doing pretty well with this. So just a quick reminder, if you're solving for the lengths of any triangle using trig, right, you take the given angle, you see what you get. In this case, I have an opposite and I have an adjacent. This would be a tan function right here. And remember, this can come in 2 flavors, one where the variables in the numerator, one when the variables in the denominator. Many of you are already starting to memorize the pattern, but the algebra behind it is easily done. This particular one, we multiplied both sides by 32. So 32 tan 56. When the variable is in the denominator, then it is whatever the number is divided by whatever the trig ratio is on the other side. That's the pattern. And most people do that rather than what I'm showing you, the algebra. The other thing that you solve for is the side angle, or the angle measurements. When you do the angle measurements, that's where we're using the inverse ratio functions. So inverse tangent, inverse cosine, inverse sine. So you'll be given, that shouldn't be there. Why is that there? That should be an X right here. Imagine that 30 degrees was not there. To solve that, you would simply do the inverse sine. So to get rid of the word A, we do the inverse of sine, which is inverse sine, of both sides. What most people remember, however, is the fact that in red here is what you type into your calculator, and that's fine. I remember taking a college class, and the professor said, well, how do you get rid of the word sine? And like everyone in the class was like, I don't know, because their math teacher never made a point that the inverse of sine is inverse sine, and that's literally what gets rid of the word sine. And I was like, well, you do inverse sine. He was like, how come you're the only one that remembered that? So like, well, I guess I had a better math teacher. Yeah.
Can't you just erase it?
You can, and that's literally what this does mathematically. I mean, that is literally. Same thing with algebra. If I have 22x and I say, how do you get rid of the 22? You do the inverse operation, and I guess, graphically, I mean, like visually, when you're looking at your paper, what are you doing? I'm erasing the 22s. Okay, so that is mathematically what the erasing function does in real life. Okay, so that's the quick review. Turns out that there are, if you involve anything that deals with angles and shapes, boys, you're dealing with anything that involves shapes and angles, and side measurements, trig is the most used math out there. I'm talking about it's more used than adding, subtracting, multiplying, dividing. I'm making a slightly exaggerated point here, but what I'm saying is that to get to the answer, it involves trig. You're dealing with anything in your life that involves angles and side measurements. It's a trig ratio or a trig function of some sort. You guys know what GPS is, right? GPS is just a trig formula. I mean, how does it know that I'm right here? It just does some trig. That's it. It is the most useful math out there for many things, but specifically the ones that involve angle measurements and side measurements of polygons, specifically triangles.
Yes.
All right, so let's see one. Here is one of many, many, many examples. Okay, it's a new idea though. We like this one in math because this is a very easy segue into figuring out angle measurements and side distances. Okay, so let's say you are standing somewhere and you look out to the horizon, and on the horizon somewhere is an object that is tall. For instance, I don't know, the Eiffel Tower. Right. Danny? One general question people always say was, well, how tall is this sucker? But they can also ask, how far am I away from that thing? Those are the two obvious questions. A less obvious question would be, how far is it physically from myself to the top? So if you're in an airplane, that would be an important question, because that would be literally how far you have to fly, right? It would be, right? This would be the ground distance. This would be the air distance, or the actual distance between the two. All of those are questions. Now, another important question would be, what's the angle between yourself and the top? All of those questions can be answered with trig. We will answer 2 of them today, and they're the easiest ones. Okay, but all 3 of those could be answered. Hey, how far am I away from it? How far is the top from me? And what is that angle? All 3 of those could be. I guess a 4th one is, how tall is the thing? Okay. All right, so I said you have to look to the horizon. Here's where I stopped paying attention, because I was like, duh, teacher, that's obvious. I don't need to listen to you. And I stopped listening to the teacher. What I didn't hear her say, Ms. Shanklin, which is, you have to look to the horizon first. I ignored that part. You have to look to the horizon first to draw your triangle. If I look to the horizon, I don't want to insult your intelligence, but where is the horizon?
It's,
Yeah, that's showing me. It's straight out all the way to the edge, or where the curvature of the earth starts. So it's a straight line. You can imagine this. Now, granted, the ground is curved, but it is a straight line visually between yourself and the horizon. Now, if the question is how tall this is, right, then you can kind of see it's obvious that you make a right triangle, right? If our question is how tall is the Eiffel Tower, then you could take a protractor, and measure that angle right there, right? We will call that angle theta. And this construction has a name, which we'll write down here in a second. The opposite of this, Danny, you're not even looking at the board. The opposite of this is, up here, there's also another person standing at the top. And from there, I don't know why I moved it over there. If you're there and you're looking at the horizon, well, it's a line out to the horizon.
That's not the horizon.
That is the horizon. It will always be a straight line. It will never be down, no matter where you are above the earth. There's always a horizon, and it will be straight. Obviously, the horizon will change because you can see further, right? All right. This is once again where I didn't listen to Ms. Shanklin, because I know she said this. She said, step number 1 is you have to look to the horizon. Now, the question is, right?
Oh gosh, it's gonna be upside down.
It's going to be upside down. But notice, this right here is exactly the same as this right here. In other words, the distance of this part of the triangle would be the height of the Eiffel Tower. This angle right here gets a different name, even though I put theta. In the next box, we're going to write the names of these 2 angles. This construction right here, and the previous construction, which looks like that. So this construction gets a name, and this construction gets a name. All right, for those of you who already look forward, you already know what these are called. Write this down, please. Box 1. If it needs to go in your book of truth, put it in your book of truth. But if you're listening to me, unlike what I did with Ms. Shanklin, right? If you need to write down. Okay, so this construction right here, where you are on the ground looking to the top, and you get this right triangle, this angle shall now be deemed called, or I shall now call it I won't call it Fred, I will call it the angle of elevation.
Yes, we were just.
I need to elevate my head from the horizon to look at the top of the Eiffel Tower. I'm sure she said that, but I ignored her. And this is why I got this one wrong all the time, even though it's a very easy trig problem. The angle of elevation starts with you looking at the horizon. The horizon is straight out. Then you look up to your target. That's what we'll define as the angle of elevation.
Can you technically use this a lot in archery?
All the time.
Let's do a math equation.
This is how snipers figure out how far the bullet needs to go. There is a special school in California called high angle shooting for military snipers, and I went to it. And That's what this school is all about, is angle of elevation, and the other one I'm about to tell you, when you're shooting up at a target or shooting down at a target. In golf, right, same thing. You're either if the target where you're trying to land your ball is above your feet or below your feet, same idea.
There's also like scope.
I have a laser rangefinder that does this calculation.
I had that for hunting.
Exactly, right, because the distance changes whether it's above or below. It's not a straight line, that's the point. It ends up being the hypotenuse, not the thing. Okay, so this is going to be called the angle of elevation. The opposite is going to be called the, take a guess.
The opposite of the angle of elevation.
That's a good one. They call it the angle of depression, right?
Oh, angle of depression.
They go dark really easy on this one. All right. I never messed up the angle of elevation. I messed up the angle of depression. I'll try to make sure that
You got depressed every time you
Why
did
is
it.
it called angle depression?
you got to ask the person who came up with it. I don't know.
Right?
I mean, I understand you have to think about it. To look to the ground, you would have to, if you look at the horizon first, you would have to depress your head down to look down.
Depression is just another word for down.
Depression is also another word for sad.
It's like, well,
But it's trig, so we are not going to be sad. We're going to be happy because this is the easy math.
Depression is nothing close to just being sad.
I think we resonate with this angle.
This is just math class. Why are we
Yeah, they're not gonna go off that because I can't speak from any authority on that subject.
if you can say that there's a depression in the floor, that just means there's a
Oh,
dent
depression.
or
There is, and
down. Or
in the military, that's what we would call it. Literally, it's a geographic feature we call it depression.
So it's just like that. It's geographic.
All right, you have this written down. Now, some of you may need to put this in your book of truth. Some of you are like, well, this is obvious, makes sense. What wasn't obvious to me was the actual construction. And when I would draw it, I would always mess up the angle of depression. So let me show you where my mistake is. This can be confusing to some. I was one of the ones that was confusing, right? Can be confusing. Get it? Get it?
Yeah, I do.
Matt still isn't paying, or neither is Danny paying
I'm
attention.
trying to make him take notes in his notebook.
Hey,
instead of
Matt.
his sheet. Yes,
1, 2, 3, 4.
yes.
1, 2, 3.
What? Easy, one of them split in half.
No, they're
No,
not.
it's just a zigzag line with some squares on the ends.
There's 1, 2, 3, 4 on this side, but there's only 1, 2, 3 on that side.
How is that
Brain.
possible?
My
It's
brain.
If you look at it, it's just what Seth said.
Like the
zigzag
middle,
lines.
like if you look at it.
I'm having a brain
perspective
issue.
of three, and then you
Man's
count back
really
at
cute.
it, perspective four, it looks like it's
Crazy.
Ah, my brain.
All right.
is-
Enough of that.
Wait, no, go back to it. Go back to it. What?
You gotta stare at this. This is holy.
Have you not seen this?
Illuminati.
No. Okay. I think-
All right, enough of that. Here we go. I'm going to show you this again, and I'll show you how I screwed this up. So I don't know why, but every single time they do angle of depression, angle of elevation, there's always a sailboat and a lighthouse.
Why?
Because that's the most
Don't know why.
It's-
But you will now notice this when you get this problem. Like, oh yeah, Mr. C was right. There's a sailboat and a lighthouse. It's either that or it's a kite and a person on the ground.
Kind of kite.
Don't know, but it's always a kite. Okay, so here we go. Depending upon whether it's an angle of depression or angle of elevation depends upon where you are at. It turns out that if you were on the sailboat, and if you're at the other one, it's the depression one. So higher up you are, typically, because you're looking down at the ground, it's depression. The sailboat is the angle of elevation. So if I'm on the sailboat, step number one, the one that I never listened to, was you will look to the horizon first. So when you draw this tonight, when you're doing your homework, I don't care whether you're doing elevation or depression. The first thing you will do is from where you're standing, you will draw a straight line out to the horizon. Okay.
No.
Okay. Now, if I am on the sailboat and I'm looking up, well, then obviously the next line you draw is that one. Clearly, this is an angle of, that is an angle of elevation. Okay. You want to see why I screwed this up? Here's what I would do. I would not screw up the angle of elevation. That one's obvious. I would screw up the angle of depression. some reason, and I'm gonna tell you right now, some of you will only hear half of this, and you will be as confused as I was. I would think this was the same triangle for angle of depression. It's not, it's a different triangle. To me, it would make sense that this angle would be called, it's not. Because step number one is always to look where? You got to look to the horizon first. This black line doesn't go to the horizon, it goes to the sailboat. So if you're doing an angle of depression, the first line you draw is not this black line. It's another blue line that goes out to, I did red, goes out to the horizon. So you ready? This angle that I'm touching right now, I know online learners can't see this. This angle right here is not the angle of depression. That's the angle of depression. Okay? I never listened to my math teacher. I figured it out later on, but I didn't figure it out the first year. Okay, that's the construction. So the construction is whether you're doing angle of elevation or angle of depression, you draw the line that goes to the horizon first, from where you're standing or wherever you're at. It goes to the horizon first, and then it goes down to your target. That will get you the right triangle, or the correct triangle, I should say. Okay. All right, who's the smarty pants out there that can tell me what's the relationship between angle of depression and angle of elevation? What? What's the relationship between the angle of depression and the angle of elevation? Angles are not parallel.
Triangle.
What?
Alternate interior.
He said it first, but yes. So I have two. Now, why are they alternate interior? Because these lines would be parallel if you're looking at the horizon. So congratulations, smarty pants. Everyone else write that down. Oh, here's your congratulations, smarty pants. Smarty
I want to buy a
pants.
pair of smarty pants.
Too bad I'm a dumb dumb.
All right,
Yeah, you should put a dum dum up there.
box 3, write this down. It turns out that the angle of depression and the angle of elevation, they're equal to each other. They're congruent. But you got to be careful of how you describe this. The angle of elevation to an object is equal to the angle of depression from the object.
You can use it to blow things up.
What? That's not me. That's not. Yes, sure.
This is how artillery works.
Yeah.
You can use it.
They don't do an angle. I've never seen I don't think that you can depress an artillery piece, but you can elevate it certainly. I'm not a gun buddy, so I don't know.
You can depress it if it's higher.
That's what
up
they
than
call
your
artillery
target.
people.
It's not like there's two ways of hitting something lower than you. Either you go higher or lower.
Or you just like bonk it all the way up.
Or you just not.
How does it go higher if it starts off
If you want
low?
it higher, it
So
will be
your
this.
angle, right? If you're shooting straight, it's gonna angle down like this, and the higher you go, the deeper your curve.
Oh,
That's how you
that's
do
what
it.
you're describing. Yes.
But if it's directly below you, it might be easier just to aim a straight line. That way,
There was the one you guys are taking physics next year, right?
Yeah.
Yes.
The one physics thing that just completely blew my mind in high school, the professor set up this. We walked into the room and he had this thing set up, and we were doing this right here, angle, elevation, angle, depression. But he had a tube. It was long, I don't know, maybe about 4 feet long. He had a tube, and inside the tube you could put a marble, right? And he had it set up on a stand.
Oh, I see where this is going.
And then at the end of the classroom, he had an apparatus. There was a string attached to it with a magnet. Back when I was your age, soda cans were made of steel, right? And he had suspended from the string and a magnet. It was an electromagnet because there was a little coil on it and there's a battery here, right? He had a soda can, and inside the soda can was a hole. And what he did was, my line's not lined up. He had it so that when he would blow through the tube, the marble would come out, it would go right inside the can. Right? And then what he said to us, he said, I'm going to set up a device on the end of the tube, a switch, so when the marble goes across it, it releases the can. So the can will fall straight down. So he said, well, he already had it set up so that when you blow the marble through, it would go inside. It was a small hole too. It would go in the can. He said, well, what's going to happen if I shoot the marble fast or slow, either one, what's going to happen to the marble?
It's gonna go in the can.
It doesn't matter how hard you blow it, whether the marble comes out super fast or super slow, the marble always goes in the can. Do you know why?
So you just kind of like grab it,
Yeah.
stick it in
Do you know why?
Magic. Magic.
Gravity.
What was I showing you right there?
When you
All the
when you
same.
flip the switch, it makes the can fall.
Why was I dropping two objects?
Because they fall the same
Because
speed.
one of them
They
is a can.
fall. It doesn't matter whether it's a marble or a can. All objects, when we negate air resistance, right? Obviously, if we drop them for a long time, air will slow things down. But all objects fall at exactly the same rate. So as soon as the marble leaves the tube, it is falling. As soon as this drops, it's falling. So if you can make a marble hit the can from a stationary thing when they're not falling, they must fall at the same rate. Doesn't matter how much this is angled up or angled down. If it can go inside the can from the starting position, as soon as it drops, both of them are dropping at exactly the same rate.
Guys, there's a
All right.
cross on top of
I
the
saw
house.
that thing and it changed my life. Like, well, changed my life in the sense that I understood gravity.
Wait, so you're telling me paper falls the same rate as a giant metal wall?
An anvil. No, paper will catch a lot more.
What's the
air.
heaviest thing in this room that I can hold?
This water.
Me.
You ready?
You're good.
You ready? It's pretty darn heavy. This is pretty darn. You ready?
Oh,
shoot. Now, usually this works. I'll do it on your guys. Usually this works. Move the glasses.
He's magic.
Water.
How did it- You just destroyed all your notes.
They fall at exactly the same rate.
Get that. That's what you get for punching in something.
All right. Back to our math here.
I'm not too worried.
So how are we going to use this? We are going to do problems that involve angle of elevation, angle of depression. So they will all be word problems, but I'm just going to say the way you don't screw this up is that you find the word elevation or depression and you draw it accordingly. I don't know why they're involved sailboats and lighthouses, but they do. Okay, so
You have to know how far away a lighthouse is to know how far away the shore is
Uh,
from a sailboat.
you do, and sailors will carry a protractor with them so that they can take the angle measurement. They actually carry a far more sophisticated tool than this. It will be a measuring device like a small telescope that would angle up they can read off. It's called a sextant, but it's basically a compass, right? Sextant means 6, not where your mind's going.
No.
All right.
Ethan, God.
All right. Okay. Calculate the distance between a sailboat and a lighthouse if the lighthouse is 25 meters tall and the angle of elevation between the sailboat and the lighthouse is 2 degrees. One thing when they do these real world problems, these numbers will typically be very small, right? If you think about it, this is 45 degrees, right? In the real world, you're not going to be standing on the ground or in the sky looking at something that's 45 degrees. 45 degrees is the sun, right? Looking up or the moon. And even that's not even true, right? Because the sun and the moon right now are not even close if you're on the equator, yeah. Our numbers are going to be really small because when you look out and you measure with a protractor, we're talking like 1, 2, 3. If it's 10 degrees, it's way up in the sky. Now, you do Pikes Peak. Pikes Peak is not 10 degrees above your feet, right? Okay, so all of these are going to require you to draw a picture. Just do a quick picture. They don't have to be detailed. So you got a sailboat and you have a, okay, and it tells me the lighthouse is,
However many.
read,
degrees.
25 meters tall, right? Further, it says we're doing an angle of what?
2 degrees.
We're doing an angle of elevation. From what to what? So that's the key, is that you know which one you're coming from to. So it says from the sailboat to the lighthouse, it's an angle of elevation. Step number 1 is always draw to the, got to draw, and I'm going from the sailboat to the lighthouse. So that's always step number 1. If you screw up step number 1, you're going to get a triangle always, and it's probably going to be the wrong triangle. So an angle of elevation comes from the blue line up a certain number of degrees, and it tells us how many degrees here. That's 2 degrees. Okay?
That's only 2 degrees.
No, that's clearly more than 2 degrees, but it's a picture. Okay? All right, so that one is 2 degrees. Clearly not to scale. What is the question actually asking?
Distance between the sailboat and lighthouse.
So is that the hypotenuse or is that the leg? The distance between the sailboat and the hypotenuse, is that the,
Tangent,
what?
so it's tangent, so it's.
Oh, you're way ahead of us. Is the distance the hypotenuse or is it the leg?
What did you just say?
Is the distance between the two the hypotenuse or is it the leg?
It's the long leg.
Okay, it is the leg. If the question says how far is it from the boat to the top of the lighthouse, then that would be the hypotenuse. So you just got to do some careful close reading. Wes has already got this problem solved in his head because he figured out that what we're trying to find is this distance right here, and he already did the trig ratio. He goes, oh, that's the, according to this scenario, that's the, and then that's the adjacent, right? So we got the adjacent, the opposite, and that's tan. So what's the real setup then, therefore, Wes?
2 equals 25 over.
Oh, so he's even going a step ahead because he knows the pattern. For the rest of us, we need to say tan 2 is equal to, okay, you sure? Okay. So tan 2 is equal to 25 over x. Now, if you have the pattern memorized, you don't need to do this algebra, but if you don't have it memorized, you need to do the algebra. On this particular one with the x's in the bottom, what we gotta do first? Multiply both sides by x. This is that weird one, because x is on the bottom, not on the top. X is on the top, 25 bottom, yeah, both sides by 25. So multiply both sides by x. The x's cancel on that side. You're left with that. Now what? How do you get x by itself now? No, that's for finding angle measurements.
Divide by x.
What are we trying to get by itself? Yes, I agree. But we're trying to get Matt on board here. How do we get x by itself? What's attached to it?
Tan.
25. How is x attached to tan 25? I'm sorry, tan 2.
Multiplication.
So how do you get rid of multiplication?
Divide both sides.
By tan 2. The tan 2's cancel, and you're left with, this is what Wes said from the start, because he knows the pattern. You don't know the pattern, then you have to do the algebra. The algebra isn't that hard, okay, but you need to do it. All right, grab your calculators. How far is the sailboat away from the lighthouse? And
715.
715, so 715,
I rounded up to 716.
so 716. Right. I didn't get 715. Mine got 716.3. Is mine wrong?
I got 17, 716.9.
715.9.
I've used this slide for a couple of years. Yeah, mine's wrong. Interesting. All right. So yeah, 716 rounded, right? Not 716.3. You change that. All right, questions? All right, we just did an angle of, so we should probably now do a
Depression.
all right. So the big button here is that, yeah. Same scenario, except this time I'm doing an angle of depression between what? That's not what it says. Between the lighthouse and the, by the way, if you're above the object, it's always going to be an angle of depression. It's not going to be an angle of elevation because angle of elevation will be above the where you're standing. Okay, so if we're high, it's going to be angle of depression. If you're low, it's going to be angle of elevation.
What if you're going up again?
Well, then it depends on which object is higher than the other one, right? Okay, so once again, the step that I forgot, step 1 is to always draw horizon line. So I draw a horizon line. I don't draw to the object, I draw the horizon line. This would be the distance between the top of the lighthouse and the sailboat. The blue line is now no longer the distance between the top of the lighthouse, but it is the distance between the lighthouse and the sailboat, right? This blue line is the distance between the lighthouse and the sailboat because I could equally draw this blue line down here. The problem is that the angle we're getting is this one right here. That's the angle of depression. Okay, so 15 degrees, we're told. Once again, the lighthouse is 25. So if the lighthouse is 25, how long is this line from the sailboat up to the blue line? It's 25, right? Because it's basically a parallelogram. Okay. If the distance between the lighthouse and the sailboat is X, that would be the bottom line, and therefore the blue line is. All right, now do you need to do what I just did right there? No, but that's the basic construction. Okay, who's got the trig on this?
Well, is it standing opposite over at front?
Okay, where's the hypotenuse? Blue or black?
Yes.
Blue or black?
Black.
Black. X isn't applying to the black line, X is applying to the blue line. You see that? It would just be tan again. Tan is very widely used for distances, vertical distances. Okay, so it's a tan again. So I got an adjacent, and I got an opposite. Matt,
15 over 25.
it's
15 equals 25.
okay. So it's that same ugly problem. Step one, X is canceled. Now what? Now you got it. All right, grab your calculator. See if I made another mistake. I hope not. 93 point, and that would be in meters. Phew. All right, that one's right. Yes?
Yes.
Danny, have you done any of this or are you drawing dragons?
He's actually not doing dragons, he's drawing some.
Okay. I'm going to say this again, Danny. Everyone in this class, other than probably you right now, is realizing this is pretty easy. If you stay with me, you're going to be part of that. If you don't, this is just complicated enough that you're not going to get it if you don't try it. You got to try it. That means I'm seeing a calculator in your hand. You're doing it, right? I mean, it's too late for this particular one, but we can do the next one. Is there a next one?
Yes.
Okay, good. All right. Oh, I'm tired of sailboats and lighthouses.
Me too.
And we're out of time. Did anybody actually do this one? What'd you get?
2.6 degrees. 2.6 degrees.
This was, there you go. Good job. All right. The only difference between this one is you are finding the angle of elevation for this particular one. All right. You have just enough information to be very dangerous on your homework. When I walk into Surratt's class during student advisement and you don't ask me a question, that's because you've looked it over and you're like, I got this. Right? But for those of you that don't got it, that's your chance to ask the questions. Please ask the questions. What? Because Miss Boyd was had a doctor's appointment, so I had to cover the 7th graders, which really made my day. Sent me home on a very happy note. Dripping sarcasm. I'll be happy next year when I don't teach them.
I feel like by next year, there's not gonna be enough teachers for 7th grade. At all.
Oh
Yeah, there will.
I forgot my.
We're getting a new, well, we have to have another math teacher because I can't teach everybody now, but we're getting another math teacher, no science teacher. History teachers we have enough of, and English teachers we have enough of. But we'll be getting new math, new science. All right, e-learners, anyone online? No one's online. If you have any questions, send me a chat or email.